So welcome, my dear students. Welcome, everyone. Just with the course of the functions, MHF4U. And here we will start right now. Yesterday we talked about what do we mean by a function. So here, if I put a vertical line like this way, like what you see in front of you right now, this is a vertical line. If it intersects the curve of the function or the function's graph in 2 points, like this intersect, then this is not a function. This is not a function. This we call it the vertical test. I said this yesterday. And I just graph it also, and I show you how to graph when I graph it. Let me just show you something. When we graphed it yesterday, it was just like here. We said here as example, if we have the row and I have insert shapes, here the shapes. And I'll take a line, and I'll take this is the vertical axis, and this is the horizontal axis. And here is the horizontal axis. Here it is. And here now, if I just graph any figure, let's say this is a curve like this way. This is a function. And then if I did the line like here, it cut 2 points, like what you see in front of you here. It cut it in this point and this point, then this is not a function. Then as long as it cut it in 2 points here, or we have 2 points here, that means this is not a function. And we said this yesterday actually, while we were working on our PowerPoint's slides. We know that the domain is for X and the range for Y. And we saw how to do the domain and the X for them. And we know how to do the restraints as well. So as example for this function, if X equals X squared, X minus 1 whole square plus 3, let me tell you something. Here we go. So if I just try to see what is the domain and what the range, the domain here, which is for X goes horizontal. So any point here represent X. So X belong to all the real numbers. X will belong to all the real numbers. But Y, if you can notice now, this Y is the vertical. So the vertical, start from 1, 2, 3. So start from 3 here. That means I cannot say that start from 0 in this point. No, start from 3 here. So 1, 2, 3. So I would say that Y also belong to all real numbers, like here, belong to all real numbers, but with a condition. This vertical line means with a condition that Y is greater than or equal 3, because Y start from 3 here. It didn't start from the point the intercepts of 0 and 0. It starts from the point 3. That's what we said yesterday, actually. We also talk about the meaning of asymptotes. Asymptotes, it gets closer into the vertical or the x-axis or the y-axis, but it never touch it. The reason for this is because if I say x equals minus 3, so here if I draw a line here like this, and this line cut the horizontal line in x minus 3, here is x minus 3. Asymptotes means that the graphs here, those graphs of functions, they pass close by the vertical x, but it doesn't touch it. It doesn't intersect it. It just go close by it, very close to it. Okay, but hey, it's a line that curves approaches more and more closely, but never touches. I think it's very clear here now. Approaches more and more closely, but never touches. So this is the meaning of the word asymptote. Usually, for any function, y will never equal 0. y will never equal 0, because if y equals 0, that means this amount is 0. How come? It will never happen, because y started from 1 here. So y will never get 0. Okay, this is another point. Then we moved also into the figures, and we said the linear, which is n the power of x, is 1. Quadratic, when the power of x is 2. Cubic, when the power of x is 3. Quartic, when the power is 4. And quintic, when the power is 5, and so on. And we said also, if you remember yesterday, we said that this one as example, which one is a polynomial? The polynomial is any function that has power. X has a power, right? X has a power 1, 2, 3, 4, 5, 6, or whatever. And it's not exponential function. It's not exponential function, and it's not a log function. And that's it. So here, and this is also not a trig function. It's not a trig function. It's not a trig function. So here we have, let's say here, gx equal sin x. This is not a polynomial. The reason, because this is trigonometric. This one looks for, this is yes. This is a polynomial. What about this one? Polynomial as well. What about this one? No, because the x here is the power. The x itself is the power. So this we call it exponential. We call this one, the last one, gx equal 3 power x. We call it exponential function. And we will handle the exponential function here in this course. Now we'll go to the interval notation like we said before. The interval notation is area for x. X in between. X in between. And I just want you to notice this now, right now. I just enlarge this for you guys so that you can see it properly. Let's go here and see it properly. Not that limit too much. That's too much. This then. So here, if I say now that the inequality means these signs, because there is no equal, it is inequality signs. It's called inequality. Greater than or less than. Okay. And I have here, I have two kind of brackets. Around brackets, and I have also square bracket. So it is, if it is like it's not like here, is not exactly, so it will be this round bracket. But here it's closed because it's equal, here equal. So this bracket is square brackets like this. You can see it here, square brackets. But here, as long as it's x is greater than -3. Greater than -3, it might be going all the way like this, any point. For that reason, I will make it with the round brackets, these round brackets, because no absolute value for here. But x here equal is less or equal to 5, so it might also equal 5. It might also equal, we put brackets like this. But inequality, we put the round brackets. Likewise, the same thing here. We said this before. And we talk about also the graphs. We talk about that we have linear. And we talk about the quadratics. And we talk about the cubic and how they looks like. So here, the linear, just a quick review. Y will equal x. This is a linear. And x here, power 1 from line. It's represented by line. Like you see, no restraints on the x and the y. The x is horizontal, the y is vertical. No any restraints. For that reason, we say they have a range and domain. Their domain for x is from -infinity into +infinity. And for the y, same likewise, because they can go anywhere here, for x or for y. And this one start in quadratic 3 and end in quadratic 1. So this is quadratic quadrant 1. This is 2, this is 3, this is 4. So start by 3 and go to 1. Second one is the quadratic, like what we say here. You can say those are quarter 1, quarter 2, quarter 3, quad 4. You can say quads. Quads is easier. Quad 1, quad 2, quad 3, quad 4. For the quadratic function, which is power 2, is power 2. Now I just want to tell you something. We start here on the x-axis. So I have restraints here, but the restraints here on the y, not in the x. X can have any value. For that reason, the domain is from minus infinity into plus infinity. So any point here can represent, any point like this can represent the domain. But for the range also has infinity. So here the range is 0 because we start from 0 here for the y. The y starts from 0. The y did not start from down. The y starts from 0. I mean by down like this. Let me tell you something. I mean by down like this. So here, if I draw, if I just want to draw like this as example, y, this is y. So we have 3 here apart. So it didn't start from the point of 0 and 0. But it should be also, it can be like this. And it goes from the point of 0 and 0, like this way, as example. So here, those are examples for the, you have to watch very well, very carefully, when you comment about the start, domain, and range, from where we start and from where we end. So here, for the y, start from the 0. For that reason, there's brackets here. Bracket means 0, because it's not greater than or less than. This is not inequality. No, not inequality sign. This is exactly. Start y start from 0, and y goes all the way up until also infinite. We said the infinite, we will give it around brackets, but the numbers which equal, we give it a square bracket. This is the square bracket. Okay, and starting quad 2 and ending quad 1. Here is quad 2 and here is quad 1. Same thing for quadratic, same thing for the cubic, but the cubic has, and also the quadratic, both of them has something we call it asymmetry. Asymmetry means that they are similar. So we have asymmetry here around this point. So if you just flip this curve on this curve exactly, it will come like exactly identical, two parts, like the twins. They looks like the twins. Here also, it's like a twins, but here is around the point 0 and 0, around the point 0 and 0. All this we talked about yesterday and in the previous lecture, and then we also talk about how to get the domain and range for many functions. And we talk about the point asymmetries. For the cubic, it takes this figure around the 0 and 0, because even if you flip it, still it's around the point of 0 and 0. That's for the cubic function. We also had, you can see a function and you can know if it is odd function or it is even function. And we said how to signalize between any of them. We talk also about the turning points, which is less than -1, less 1 than the degree of the function. So as example, if a function, let's say its degree is even, and it has how many turning points? It has, what are the turning points? The point where the curve turn. So here as example in front of you, here it's going like this, then all of a sudden the first turn, then this is the second turn, then this is the third turn. So we have 3 turns here for the function, which means that we add 1 to this. So the degree will be the number of turns plus 1. So 3 plus 1 will give me 4. How about the intercepts? So this is the intercept. The intercepts are 4 as well. So the even will be 4 intercepts. How about here? So the degrees on the intercepts goes equal to each other. They goes equals either in the even, like here, or in the odd. The number of intercepts and the degree, they are the same. But the turning points, or which was the turning points are less one, or less one. You can know as example now functions like this. Function like this, the power is 4. Why the power is 4? Or the degree is 4? Because the largest degree for the x's is 4. Okay. And here, the leading factor is minus. So I'm expecting that it will start from in the minus area. By other meaning, it will be like this, guys. Just 1 second. It will be in this area, in the minus area. It might be here or here and there. Let us, as example, it might be in this area like this and goes into this area. Okay, this is a function. And because what? Because it started with the sign minus, like here, like what you see here in front of you. It starts with the sign here, minus. This is minus. For that reason, it's in the negative area. And it's even. That's fine. And like I said, it will go from quad 3 to quad 4. Here we can see here. This is quad 1. This is quad 1. This is quad 1. This is quad 1. This is quad 2. This is quad 3. And this is quad 4. So like you see here, it goes from quad 3 to quad 4. Okay. Possible number of intercepts, it take the same degree. But wait a minute. Yeah, it take the same degree. So I have here as example 4, then 4, 3, 2, 1, 0. This is the number of intercepts. How about the turning points? Turning points are less 1 than the degree. So 4 minus 1 will be 3. So I might have, but I will have here odd number. In the even degree, I have odd number of turning points. So I will have 3 or 1. There is no 2. There is no even. Take care. So here, the degree of 4, I will have 3 turning points or 1, but I cannot have 2 turning points. However, for the intercepts, I will have all the types from same, starting from the same degree and going down till I reach the 0. 0 means there is no intercepts with the x. And this is possible. It's possible for the even degree. For the even degree, it's possible. Yes, it might or might not go to the x. Let me show you. This goes, it makes intercepts with the x. Sometimes it doesn't go like this. Sometimes it goes like this. Let me show you. Sometimes it doesn't go like this. Sometimes it will go, let us take this figure out. Okay, Control and Y. Okay, it might do not intercept here in this as example. If it is like that way, guys, if it was like that way, suppose it was like that way, then it didn't cut the intercept here. It didn't cut the x-axis, absolutely, didn't cut it in points. But like this one, it's cutting, there's 2 intercepts here for x. There are 2 intercepts for x. So this is the difference, because we said when it's x, it goes into 0. Yes, possible. But if it is odd degree, it doesn't cut the x-axis. Like what you saw here exactly. So here for the odd degree, we have 4, 5, 4, 3, 2, 1, but there is no 0. There is no 0. So it must, the meaning of this is that it must cut the x-intercept. But 0 here, it means it might cut it, it might go on intersect with the x-axis, or it might does not go, like I showed you. We go also to the degrees, and we said the difference degree, the first difference, the second difference, the third difference. And I said we get it like this as example. How did we get this 29? Minus 16 minus 45, that will give me 29. So let me show it in the calculator. Let me show it to you on the calculator here right now. Let's say like this, it was like this. Here we go. Okay. I'll just make the calculator, put the calculator so you can see this number here. So how did I get this first degree? First degree or differences. Minus 16 minus 6. Then minus will be positive. Positive 45. That will equal 29. Any number minus the previous number. Any number minus the above number. Okay. How many differences I have here till I get to be similar? I got it from the third difference. The third difference is similar, 6. So here it's 6. And the degree is 3. Degree is 3 because of what? This is 1 degree. This is the second degree. This is the third degree here. It became similar in the third degree. Okay, guys? And this is how we get sometimes to know the factors of the function and so on. Okay? And we had examples also, see the example, and I put for you an example for solving the exercise, how to do it. That was another ideas, and we talk about here in that examples also. We had it yesterday. Look at this one as example here. Look at this one. This is very nice example. It show, make it very closer to your brains. How it works. So I see here the function, how I will get the degree. I will multiply x by 1 by x, sorry, by another x by 3x. So x multiplied by x squared multiplied by x cubic, x power 3, multiplied by x power 4. So the degree is 4. The degree is 4. Remember, when we multiply when we multiply these x's, we will add the power. Because it's already x power 1. Each one of them, this x power 1 multiplied by x power 1. So those will be x power 2. Multiplied by x will be x power 3. Multiplied by 3x will be x power 4. So the degree is 4. The leading coefficients, how did I get the leading coefficients? Because I have here, this is 1. 1x, this is 1, the second one. This is the third one. And this is the 3 in front of the x, the fourth one. So 1 times 1 times 1 times 3, the leading coefficient would be 3. When you multiply them, the leading coefficient will be 3. So even degree, and also it is positive or negative. What do you see here? It's actually positive because here there is no negative sign. If you multiply the x's together, they are all positive. So a positive. Okay, positive and even. So we have from Q2 to Q1, we will work in the positive area here. Q2 to Q1. How many number of intercepts? We'll see how many numbers we have. We have this point of intercept. 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 So we have 4 points of intercept. The degree is 4, and we have 4 points of intercept. That's fine. How about the y-intercept? When you just put 0, because x here is 0, and the function here, so let x be 0, 0 minus 1, it will be minus 1 here. X plus 3, so here 0 plus 3, it will be 3. Here it is, the 3. This is the 3. 1 plus x, so 1 plus 0 is 1. Here is the 1. And 3 multiplied by 0 Any number multiplied by 0, it will be 0. Minus 9, this is the minus 9. So when you do all this multiply minus 1 times 3 times 1 multiply by 9 minus 9, that will give you 27. So the y-intercept is 27. So here the y-intercept will be 27. Now you got the solution for this example. And by the way, guys, when you come to see how did we get these intercepts without graphic, even without graphing, we say all this will equal 0. Assume that all this will equal 0. So if we say x minus 1 equals 0, then x will equal 1. Hit the point 1 and 0. If x equal here, this is 3, x plus 3 equals 0. Then x will equal minus 3. Here is minus 3 and 0. The third point, 1 plus x will equal 0. Then x will equal minus 1. You know what? How did I get it, this, guys? How did I get it? I will tell you. This amount multiplied by this amount, multiplied by this amount, multiplied by this amount, I will make it equal to 0. I will say all this equal to 0. Just 1 second. I will assume. Wait a minute. We can do it here right now. So I will say that this amount, like this, here it is, and I will take it here, edit and copy. Then I will go to a page here, like here, and I will go down this page. Let me say like this, that I will put it here. Let this amount, Control and V, this equal to 0. Equal to 0. Okay. Then this might be the 0, or this might be, because those are multiplied by each other. So I would say, as example, x minus 1 equal 0. Let me enlarge it, please, so that you can see it, guys, properly. X minus 1 equals 0. Then, as long as that, so I will take this one to the other side. I will take this one to the other side. X, but in that case, the signal was negative, but it will turn here into positive. So 1 plus 0 equal 1. So x will be in this point 1, and that's what was there here. So x here equal 1. And the other point 0. The other point is 0. Means y is 0 here. And minus 3, same thing. Here, I would say x plus 3 equals 0. So x will equal minus 3. Here it is. 1 plus x equals 0. Then x will equal minus 1. And the last one, 3x minus 9 will be 0. So 3x will equal 9. So x will equal 3 here. X will equal 3. And of course, on the y-intercept, it's all 0 because I'm seeing the points which intersected with the x-axis. So I am just freezing the y for the moment to get the points of axis. Okay. We went after this symmetry, and the types of symmetry. And we said we have 3 types of symmetry. We have the even type, if all the degrees are even. Even type, when all the degrees even type, like this way, it looks like this, it goes from Q2 to Q1. That's what, when we use it, when we do this, when all the powers are even. How about the odd? If the power is odd, then like 1, 3, 5, 7, x power 1, x power 3, x power 5, x power 7, then in that case, it will take this figure. And actually, it's around the point 0 and 0. So the similarity is around, so this part, like this, the similarity means what? Or asymmetry means what? That they are similar to each other. So this part here, like this, is similar to this part, exactly. It's similar to this part, exactly. For that reason, we say asymmetry or asymmetry. So means it's okay. So here the odd means the power is x power 1, or x power 3, or x power 5, or x power 7, etc. How about the neither? The neither is a mixture between even and even functions, which is power 2, power 4, power x power 2, x power 4, x power 6, and odd function at the same time, like x power 1, x power 3, x power 5. So that's how it works. I will show you right now this is an example here. It will show you the idea so that you understand. Now, the x here is power 4, and the x here is power 2. What do you think? Because here, those are even numbers, so it is even. The function is even. Here, power 3, and this x is power 1, but we don't write the 1. 5 power 1 is 5. 4 power 1 is 4. 3 power 1 is 3, and so on. So this is odd function. This is odd function because it's 1 power 3 and 1 power is 1. How about this one? This. Actually, this is neither odd nor even. By other meaning, because I have here power 5, and this is even. This is odd, 5, and this is even 2. For that reason, it's neither even nor odd. Okay, guys? Likewise, you have another example. You can do it. You have another example. You can do it as well. So here the intercepts on -1 and 0, 2 and 0, 4 and 0. These are the intercepts. And we have how many turning points? This is one turning point, second turning point, third turning point. And what about the least possible degree? We can get from the number of intercepts. The number of intercepts are how many? 1, 2, 3. So it's the possible degree is 3. And the coefficient is minus. The reason why? Because it's in the area of the minus area here. Here. So the leading coefficient would be minus. Any symmetry? Symmetry? There is no symmetry here. No symmetry, absolutely. Here it is. You can see here. The number of turning points is 3. So the degree will be 3.1 will be 4. Any symmetry? There is no. Okay, guys, no symmetry here. What about the domain? The domain. You can see here now, for x, -1 and minus, this is start from infinite minus and -1. And from -1 and 2, -1 and 2, this is the second. And the third one is 4 to infinite. So it goes like this. From minus infinity to -1, this is -1 here. From minus infinity, this is minus infinity like this way. It's going till -1. And then after that, from -1 here into 2, this is the second part. Then from 4, the last intercept here, 4 till infinite. And we can see also we put it in round brackets here. That was our first part. We'll get back to the next point. Thanks a lot.